Good morning, this is Mr. Coleman with the next video in the series Maths Revision Outside the Classroom. The title of this video is Pythagoras and Trigonometry. Now, Pythagoras and trigonometry are usually used for finding angles and sides in right-angled triangles. In this video we're only going to deal with right-angled triangles, not going to deal with non-right-angled triangles. Though if we have an isosceles triangle, it is possible to divide that down the middle to make two right-angled triangles. So you can use the techniques described for isosceles triangles simply by dividing the isosceles triangle down the middle into two. Right, so let's start with Pythagoras. Pythagoras' theorem deals with just the sides of right-angled triangles, so there's no angles involved apart from the fact that the triangle must be right-angled. Pythagoras' theorem says that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So you square the numbers on the two short sides to get the square of the number on the longest side. The theorem goes a squared plus b squared equals c squared, where a and b are the two short sides and c is the long side. The long side, incidentally, is always called the hypotenuse and it's opposite the right angle. So if the two short sides are 3 centimeters and 4 centimeters, we simply square them. 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. We add them together to get 25, and that gives us the square on the longest side. So to get the actual length of the longest side, we need to take the square root. The square root of 25 is 5, so therefore the length of the longest side is 5. Because we add to find the square on the longest side, a simple rearrangement of the formula tells us that we would need to subtract to find one of the lengths of the shorter sides, one of the shorter lengths. So, if we're trying to find the length of a triangle where the hypotenuse is 13 and one of the other sides is 12, we would simply work out 13 squared, like before, is 169, and 12 squared is 144, but this time we need to subtract, because we're finding a shorter side. 169 minus 144 gives us 25, the square root of 25 gives us 5. So the length of the other short side is 5. Suppose we have two sides of a triangle are 10 centimeters and 6 centimeters, and we want the third side. We simply square the 10. 10 squared is 100. Square the 6. 6 squared is 36. Providing the side that we want to find is not the hypotenuse, we subtract them. 100 minus 36 is 64. Then take the square root. The square root of 64 is 8. If, however, we wanted to find a longer side, if the 10 and the 6 were both the shortest sides, we want to find the longer side, we would add the squares. 10 squared, 100. 6 squared is 36. We'd have 136 when we add them, and we'd then have to work out on our calculator the square root of 136. So that's Pythagoras. Now let's move on to trigonometry. We use trigonometry when angles are involved. Still, the triangle should be right-angled, of course. If we are given two sides and need to find an angle, we first mark the required angle, just with the usual little curved line to indicate the angle that we require. The side opposite that angle is called the opposite side. The longest side is called the hypotenuse, and the side next to that angle, the third side, is the adjacent. There are 3 rules you need to know. Sine is the opposite divided by the hypotenuse. Tangent, the tangent is the opposite divided by the adjacent. And cosine, the cosine of an angle, is the adjacent divided by the hypotenuse. It's easy to remember these using the mnemonic SO, CA, TO, A. Sine, op, hype, tan, op, adj, cos, adj, hype. So when you're given a triangle and given two sides and asked to find an angle, you label just the two sides that you're given. Just the two, not all 3. If those two sides are the opposite and the adjacent, we know we use tangent. We simply divide the opposite by the adjacent, and then on our calculator, in order to find the angle rather than just the tangent, we need to do the inverse of tangent. That's usually found by pressing the second function button, or the shift function button, or the inverse function button. Whichever button your calculator has, second, inv, or shift, you press that and then the tan button, and it will give you the opposite of tan and enable you to find the angle. If the two sides that we'd marked were the opposite and the hypotenuse, we do the same thing, opposite divided by hypotenuse, but then we do shift and the sine button. If we were given the adjacent and the hypotenuse, we would do adjacent divided by hypotenuse, shift, and then the cos button. If, however, you're given an angle and asked to find a side, you will also be given one of the other sides. You label, then, the side that you're given and the side that you want to find. So again, just the two sides. If they are the opposite and the adjacent, and suppose the side you want to find is the opposite, then you know you're going to use tan again. So say the adjacent was 10 and the opposite you wanted to find, and the angle was 30 degrees, you would say tangent or tan of 30 equals op, which is x, over adj, which is 10. So you'd get tan 30 is x over 10, which you would then rearrange so that x is 10 times tan 30. Okay, if you were given the opposite and the hypotenuse, supposing the opposite side was 5 and the hypotenuse you didn't know, opposite and hypotenuse tells you to use sine. So if the angle is 40 degrees, sine of 40 degrees is 5 over the hypotenuse. 5 divided by the hypotenuse, which you don't know. When you rearrange that, it becomes a division, because the number that you know is on top. So to get the hypotenuse, you would do 5 divided by tan 40 degrees on your calculator, and that will give you the answer. Make sure your calculator is set to degrees. One last example, suppose we are given that the adjacent side is not known and the hypotenuse is 12 and the angle is 65 degrees. We know we're given opposite and adjacent, we label those, and that tells us, you know you're given adjacent and hypotenuse, and that tells us to use cosine. So we would say cos of 65 equals the adjacent, which we don't know, divided by 12. So adjacent over 12 is rearrange that, the divide goes to multiply, so the adjacent side is 12 multiplied by cos 65, which we do on the calculator. So I say you can use these rules for other types of triangle, providing you first divide them in such a way as to form a right angled triangle. And you can also use them to find missing lengths in practical situations. So for instance, the length of a ladder going up a building, provided you knew the height above the building and the length from the building. You could then use Pythagoras to find the length of the ladder. Or if you were given one of the angles, you could use trigonometry. Well, I hope you found this video useful. You should now go away and practice some questions. Until the next time, goodbye.